Hi friends, this is Hemadri working as assistant professor in RMK College of Engineering and Technology in Mechanical Engineering. So today I am going to discuss about heat treatment process. In this heat treatment process, first we will see the various types of annealing and normalizing process. So first we have to know about what is meant by heat treatment. So heat treatment means we can take the steel slowly heating up to some temperature and then holding a time temperature for some time and then slowly cooling to the room temperature. So here total three parameters are involving. First one is heating, holding time and cooling. So we are doing like this, so the properties of the material will change, that is it may be physical, chemical properties. So why we have to do this heat treatment means we have to improve the properties of the materials. So that's why we are going for this heat treatment process. So what are all the major purpose of this heat treatment means? So we can improve the ductility of the steel and we have to reduce the relieving these internal stresses. So normally during casting, welding, some internal stresses will generate in the material. So that stresses and all we can remove by using the heat treatment process. And we can refine the grain size and we have to increase the strength and machinability and toughness. So these are all the major properties we can improve by using the heat treatment. So next one is what are all the major factors it will be affecting this heat treatment. So what first one is temperature, up to what temperature we are heating the material, and then next one is holding time. So next one is rate of cooling, that cooling time. So these are all the three factors it will affect this heat treatment. And then we can see the classification, bulk and surface. So here the majorly the heat treatment it is involving into major classification is first thing is annealing. In this annealing again we are having the sub classification and normalizing process. Next one is hardening and tempering and harsh tempering, mar tempering. So this is coming under heat treatment process. And surface, so only the surface alone it will change. So this one it will be having the two major classification, thermal and thermochemical. So thermal means flame hardening, induction hardening, laser electron beam hardening. And thermochemical we are having the carburizing process, nitriding and carbonitriding process. So this is about heat treatment classification. So this is called the in ion carbon diagram. So we are having the two temperatures, A1 lower critical temperature and A3 upper critical temperature. So here we have marked the various types of annealing. So we can see one by one. So first we will see the what is meant by annealing. So annealing means it is a process of heating the material to a temperature and holding that particular temperature for some time and slowly will cool to the room temperature. So because of this heating the material and holding time and slow cooling, the microstructure of material it will changes. So it will give the good properties, that is called strength, hardness, ductility. It will relieve the internal stresses. So all these properties will change. So this is called annealing. So these are all the major purpose of annealing. So where we can use this annealing means we are using this annealing process for casting products, forging, rolling, extrusion, all these products we can use this annealing. So these are all the types of annealing: full annealing, process annealing, stress relief annealing, recrystallization annealing, spheroidized annealing. So we can see one by one. First we will see the full annealing. So full annealing means, so we can take this hypoetic toid steel, that is 0.77 percentage carbon. We are heating up to 723 to 910 degrees centigrade. We have to wait for some time. Entirely it will be converted to austenite, then slowly cool to the room temperature. So here what will happen means, so before heat treatment, the structure it is in very coarse form, the grains are it is in very large grains, and then the grain size after heat treatment it is in fine size, and then the properties also will increase. So it has good soft and ductile, low hardness. So these are all the major properties. You will see here, this is called full annealing. More than upper critical, that is more than 19 degrees centigrade we have to heat, and then slowly cooling. So the structural difference it will have. Next one is recrystallization annealing. Normally this annealing when they will do means, for any cold working process, so the material it will be become very harder. So because of this hardness it will lose this ductility. So we have to improve the ductility. Again we have to do the recrystallization annealing. So here we have to take this alloy below this lower critical temperature. We have to heat and then slowly cooling. Heating, waiting for some time, and then you can cool. So then the structural changes will occur. So the grain size will have difference. That is called recrystallization annealing. So next one is process annealing. So process annealing means, this is called process annealing. So it is same like this full annealing. So here the cooling rate is below the lower critical temperature. So why we have to do this means, it will increase the ductility. So where it will be used means for sheets and wires. So for sheet metal process we can use this process annealing. So normally what type of parts? This stamping, extrusion, offsetting, drawing, all this process they will use this as one heat treatment process. Again it will reduce this oxidation also, that is called scaling. That oxidation resistance, corrosion resistance also it will be very high. So next one is stress relieving annealing. Stress relieving means, I told you already. So during the cold working operations, so the internal stresses will form in the material. So these internal stresses we have to remove. So for this we can do this annealing process. So for stress relief annealing also we have to heat below this lower critical temperature and waiting for some time, then slowly cool to the room temperature. So this process we can call it as a stress relief annealing. So what are all the major causes of this residual stresses means? Thermal factors, mechanical factors, and metallurgical factors. So next one is spheroidization annealing process. So this spheroidization annealing process, especially we have to use for this before this hardening and tempering. We have to do this spheroidization annealing. So it will increase the ductility of the material. So we have to heat below this lower critical 650 to 700 degrees centigrade, and slowly we have to cool in the furnace. So the structural change, that is called spheroidite, in which we can call it as a ballad of. So it will be having this round ball that spheroids form. So because of this the machinability it will less. So we have to improve this machinability. So for a high carbon steels and all, we can use this periodization annealing process. So this is called periodization annealing. So these are all the applications of annealing: casting, forging, presswork, rolling stocks, etc. So next process is normalizing. So normalizing is also same like annealing, but normalizing process we have to increase more temperature compared to the annealing process, and then for normalizing we are cooling in the air. So this is air cooling, annealing is a furnace cooling. So for annealing it will take more time for cooling, but normalizing the cooling time is less, and process time also it is very less, but properties also compared to annealing, normalizing it will give the good more, it will increase the strength, ductility and everything is fine. So for normalizing we have to increase the steel, heat the steel up to 40 to 50 degrees above upper critical temperature, then we have to wait for some time. So why we are waiting means the structure it will be converted to entire that uniform structure. So then we are cooling slowly in air to the room temperature. So here after normalizing the structure is, it is having the pearlite structure it will form. So here we can see the final structure, we are having the ferrite and cementite in the final structure of normalizing process. So what is the difference between this annealing and normalizing? We'll see. Annealing, the coarse lamellar pearlite, the pearlite structure is very coarse. So here it is very medium lamellar. So we can see the difference, medium lamellar. And then for annealing it will have the more time, normalizing it will have the less time. It will be having more stronger and harder compared to the annealing steels. So that's why the normalizing we can do compared to annealing process for some specific applications. So these are all the purpose we are using for normalizing. We have to refine this grain structure. It will reduce the residual stresses, increase this machinability. So these are all the major purpose. So now we have seen about what are all the various types of annealing and then normalizing process. Thank you.